Welcome to T3 Day 18 of Calculus. Today we're going to continue our discussion of antiderivatives and trig functions. Now first, here is the big list of all of the trig derivatives that you need to remember. So derivative of sine is cosine, derivative of cosine is negative sine, tangent is secant squared. I prefer writing it as secant squared, but sometimes you need to simplify. So you need to write secant squared as 1 over cosine squared. And the derivative of ln, natural log, is 1 over x. So what that means is if you go in reverse, you know the integral of each of these. You know the integral of those four things. So the integral of the antiderivative of cosine is going to be sine x plus c. So you have the plus c here, and it's just everything in reverse. The other key thing to realize is that when you take the antiderivative of 1 over x, you get ln of the absolute value of x, because you can't take the natural log of a negative number, so you throw in that absolute value sign. So here are some things that you just need to know. So let's use our skills and attack these indefinite integrals. Indefinite because they don't have limits of integration. So the first piece, we do them each one by one. It's going to be x to the third, and then you're going to have that 3, and then you have that 2 right there that you need to make sure is there. So then here you have 3, and don't do the same thing there because that's 1 over x, and the antiderivative of 1 over x is natural log of the absolute value of x. You have to remember that like this. So this one goes right there. And then you're back to the safe space of what you had before. That's just going to be plus 6 times. What's it going to be? Remember, you go up 1. So it's going to be x to the negative 1. So it's going to be negative 1 and, well, we can put the 6 there. That's fine. It's the same format we had before. So 6 over negative 1. Because when you take the derivative of this, you end up with positive 6 out front and negative 2. So then it's plus c. So let's go over here. Let's simplify a little bit first here. 5 over cosine squared is 5 secant squared x. And I'm just going to write it out because I like to flatten the whole thing out first. That's just my preference. And then you just need to remember, is there something here? Is there something here that, what is the derivative of what is secant squared? The derivative of what is secant squared? Well, it's that. So it's tangent. It's tangent. So this is going to be right here, 5 tangent x. And then the derivative of what is cosine? The derivative of what is cosine? Well, we know the derivative of sine is cosine. And it's also explicitly stated right here. The antiderivative of cosine is sine. So this is going to be minus, remember that 4 is just along for the ride, sine of x. And the key thing here is the derivative of what is sine? Well, it's going to be negative cosine. So it's going to be plus 2 cosine x, because negative times a negative is a positive. So it's going to be then plus c. The derivative of cosine is negative sine, so that's what makes the negative sign right there. So let's take a look at this right here. So in this question, we're back to the nice line of just finding derivatives. We're just trying to find the derivative of this function. So what do we do here? Well, the derivative of cosine is negative sine. So f prime of x is going to be negative sine. Remember, this negative is along for the ride, and the derivative of cosine is negative sine of x squared. But then you need to do the derivative of the inside because of the chain rule. So this right here, this part right here is because of the chain rule. So when you keep doing this out, these two negatives out front cancel each other out. You end up with sine of x squared. That's the first part. And then what's the derivative of x squared? Well, that's just 2x. Nice. So now let's look at this next one, which is going the other direction. What is the antiderivative of sine of 2x x squared, or 2x sine of x squared? Now, if I had just given you this off the top, like right here, without doing this one first, it'd be a much different problem. It'd be a lot harder. But look, we have this. This and this are the same. So what does it tell you the antiderivative of this is? Well, it tells you that the antiderivative is going to be that right there. This right here. Negative cosine of x squared. We know that because we just did out the derivative. So basically, this is a huge hint about how to do number 4. So let's go back to an old standby awesome question type that we like, finding the equations of tangent lines. So we're trying to find something that's tangent. What's the equation of the line that's tangent to this function at x equals pi over 4? And it's still just a hunt for the slope and the point. Now the easier one is generally the point. And we know that the x value is pi over 4. And then you have to plug in pi over 4 into the function itself. So when you do that, the pi over 4 is still there for x. And then you have 3 cosine of 3 times pi over 4, like this. So you're trying to find out what is that y coordinate. You need to go further. So it's cosine of 3 pi over 4, like this. Oh, and it's, sorry, there's a plus 4 right there. Excuse me. So this right here is plus 4, plus 4. Look at that right there. You need to remember what the cosine of 3 pi over 4 is. And that is going to be negative root 2 over 2. So you have pi over 4, comma, 3 negative root 2 over 2 plus 4. So there's your point. We just found the point. Now we need to find the slope at that point, at that specific x value. So we need to find the derivative first of this function. So we're talking about f of x. I'm just going to write it again. 3 cosine 3x plus 4. When we do the derivative of that, the derivative of cosine is negative sine. So it's going to be 3 times negative sine of 3x. But because of the chain rule, we need to make sure we multiply by 3 on the outside. And the derivative of 4 is just 0. So we have f prime. Let's clean it up a little bit here. Negative 9 sine of 3x, like that. So now we're doing it when x is equal to pi over 4. So we need f prime at pi over 4. So we need negative 9 sine of 3 pi over 4. And the sine of 3 pi over 4 is just root 2 over 2. The sine of this right here is just root 2 over 2. Please review your unit circle if that's not making sense. Please do. Negative 9, and then this is just going to be root 2 over 2. So what do we have now? We have the slope. We have the point right here. And we know the point slope form is y minus y1 is equal to m times x minus x1. So now we just plug things in. Y minus, and that's right here, that's this one. It's going to be negative 3 root 2 over 2 plus 4. Notice the brackets, equals the slope, negative 9 root 2 over 2 times x minus pi over 4, because that's the x value we're at. And you would stop right here. Please just stop right here. Stop. That is totally fine. I like how it's written like that. So now we're going to find the total area between the x-axis and the function y equals sine x from 0 to 2 pi. So as a good exercise, especially now, as we're working with trig functions more and more, let's graph this. What does sine x look like? Well, sine of 0 is indeed 0. So then sine goes up, goes down, and it comes back at 2 pi right there. Right there. Okay, so what are we looking at? Total area. So the total area is going to be this right here, and then adding it to, well, I'll use a different color. We like using different colors here. Use different colors here. So there's a couple ways we can set this up. So first of all, it's asking for total area. So we know that the interval that we like to, if we were just going to use our calculator, so if we were just going to use our calculator, it would be 0 to 2 pi of the absolute value of the function sine of x dx. So we could use our calculator and figure that out. But if we were not to use our calculator, we need to break it into 2 integrals. And it's going to cross at pi right there. So it's 0 to pi, and this is the blue area of sine x dx. And then what are we going to add to that? We add the opposite of the integral from pi to 2 pi of sine x dx. These are the same. These are the same. Total area means we want to count everything as positive, not above and below. Okay, so we can do that separately. And here's the last thing I want you to recognize too. There's another way to set this up. These two curves, this area and that area, are going to be the same. One's going to be positive, one's going to be negative, but they're reflections of one another. So what you can do instead is just double the first one. The reason I like the first one is it's 0 and pi. They're both, one's 0 and the other one's positive. So it's kind of the nicest numbers to plug in. So if we were to evaluate, there's 3 different options here. This is the one where you'd use your calculator. You could do this. The second one is a little longer by hand. This would be the shortest one by hand. So if we do that, it's going to be 2 times the derivative of what is sine? Well, that's negative cosine of x, and we're evaluating it from 0 to pi. So it's going to be 2 on the outside like this, and then it's going to be cosine, negative cosine of pi minus negative cosine of 0. By far the easiest thing to do is mess up the negative signs on this. So simplify it a little bit first. You get negative cosine of pi plus cosine of 0. This is where you have to remember a few things. First of all, cosine of 0 is 1. So you have negative cosine of pi plus 1 like this. And cosine of pi is -1, so you have 2 times -1 plus 1. So we end up with 2 times 2 is 4. Keep in mind, if I just asked you for the integral, like if I asked you for the integral from 0 to 2 pi of sine x, this is not the same thing because this is going to treat this as positive and this is negative. This would be net displacement. Net displacement. And if you did that, since the blue is equal to the yellow and the yellow is negative, this would be 0 if you went from 0 to 2 pi. But since it's asking for the total area, it's like how much land is being enclosed by these shapes, the answer would be 4.